Well, guys, we've made it to Chords and Arcs 12.2, your second video for tonight, and let's talk about them. So we did talk a little bit about a chord in our graphic organizer. It's a segment whose endpoints are on a circle, so it does not have to cross through the middle. And then we're just going to jump right into some theorems. Again, like I said, with this chapter, there is a ton to memorize. So I'm going to just go ahead and show you everything that I want you to write down, but I want to go over it. You guys, you really should listen. Within a circle or congruent circles, congruent central angles have congruent arcs. So if you know that two circles have congruent central angles, then they also have congruent arcs. The converse of that is within a circle or incongruent circles, congruent arcs have congruent central angles. Right, so it's just the same thing, just flip-flopped. So let's look at this circle. If we know that angle AOB is congruent to angle COD, which those are vertical angles, so we do know, then we can know that these arcs, this little arc from A to B is congruent to this arc from C to D. And then on the converse of that, if we flip that around, if we know that these arcs are congruent, AB and CD, then we know that these angles are congruent. So that's theorem 12.4. Okay, you're going to need to remember those to solve things algebraically. Let's look at theorem 12.5 then. All right, within a circle or congruent circles, congruent central angles have congruent chords. So congruent central angles again, but this time with chords. So within a circle or congruent circles, congruent chords have congruent central angles. That would be the converse. So, let's look here. If we know that this segment AB is congruent to this segment CD, then we would know that this arc would be congruent to this arc, AB and CD. So technically, I guess what we're not really talking about, even though it says, would be central angles, we can also say arcs and arcs again. This diagram doesn't really demonstrate a central angle, but let's say I penciled in an angle right here and an angle right here and went ahead and called that O. Then we would know if these two angles were congruent, then these chords would be congruent. Vice versa, if these chords were congruent, then these two angles would be congruent. So that is theorem 12.5. More than anything, I just want you guys to know that if you have congruent angles, you have congruent arcs. If you have congruent arcs, then you have congruent angles. If you have congruent chords, you have congruent angles and arcs. And if you have congruent chords, and vice versa. Oh, kind of tongue-tied. We'll go over this, like applying it more tomorrow. Lots more theorems. Here we go. All right, so let me get this page up here. Within a circle or congruent circles, chords equidistant from the center are congruent. All right, well, I think the picture will help explain that more. And then let's talk about the converse. Within a circle or congruent circles, congruent chords are equidistant from the center. So, within a circle or congruent circles, chords are equidistant from the center. So, here's two chords. All right. If we know that OE right here is congruent to OF, then we can say that AB and CD are congruent. As long as we know that these are equidistant from the center, then we know that these chords are congruent. And the same thing, if we know that these two chords are congruent, we know that they're equidistant from the center. Okay. Theorem 12.8. In a circle, if a diameter is perpendicular to a chord, then it bisects the chord at its arc. So if we have a circle and we have a diameter, right? A diameter goes right through the middle, and it's perpendicular to a chord, say that it's perpendicular, then we know that it bisects that arc. That means that these two arcs would be congruent. So we have a chord, it's perpendicular to the diameter, then we know it bisects that arc and the chord. So these would be congruent as well. Okay, theorem 12.9. In a circle, if a diameter bisects a chord, then it's perpendicular to the chord. So this is just saying we know, here's our diameter, here's our chord, we know that if it bisects it like this, then we can say that it's perpendicular. And then we also know these two arcs are congruent. So if it bisects the chord, we know it's perpendicular. If it's perpendicular to a chord, then we know that it bisects it. And the last one, in a circle, the perpendicular bisector of a chord contains the center of a circle. In a circle, the perpendicular bisector of a chord, so right here, it's your diameter, contains the center of a circle, i.e. must be diameter. A lot of theory. We'll put it into practice tomorrow. I really hope that you're actually paying attention to what you're writing down or what I'm saying. All right, bye guys.